Okay. So just thank you everybody for attending this meeting or this short webinar. This is in an effort for the Southwest chapter to kind of reach out to our chapter members and have a conversation just about anything in particular. As I said before, for some people that may not have been on, is we send out these monthly kind of communications, or at least try to do a better job of it. So if there's any ever a topic that someone is looking to know more about, or is if there's somebody out in the field right now that wants to present something, these are not the national tech talks. This is just something for our chapters and such, so that we can be more informed and share a little bit of the secret sauce with everybody. So with that, I'm going to introduce Marcus Sylvester. He is a co-worker of ours, and so I'd like to thank him for his participation in doing this. And I believe you've got 34 years in the water treatment sector. So with that, Mark, I will give it to you.
All right, thanks, Vince. I truly appreciate that, and I appreciate this opportunity to present to the chapter. Haven't quite been in water treatment for 30 to 40 years, but spent significant time in there, and I have the slide. I'll address that, but just want to check. Are you seeing my screen? Yep. Okay.
Yeah.
All right. Perfect. So, kind of the course description. Just what kind of wanted to go through this is by plan on discussing some of the major water systems that do require commissioning services or should have commissioning services involved in that. I want to discuss some of the implications of poorly or overlooked systems out there in these new buildings, some common issues in construction that can affect water containing systems. And then the final bullet is, I just added that as we were talking there before, water quality does matter. We got some folks from Denver where you've got, much better water than we do, say, here in Phoenix or in Albuquerque or Tucson. So water quality does matter, and some of this, some of the issues that we face here in the desert Southwest, you may or may not see in the Pacific Northwest or in the Denver area, but you'll have your own issues and concerns with different water quality that's there on your site. So some learning objectives that I want to get to. Number one, I want to be able to identify the water systems and what areas should be checked. Number two is know the ramifications of not starting up the water system correctly. I'd like to get the contractors and the water treatment vendors on the same page. And bullet point number four, having spent 16 years directly in the water treatment field, nobody likes the water guy in new construction. But we and they are okay some of the time, but we're kind of a necessary evil. So kind of my background is I've spent 16 years with Nalco Chemical, which at that time in the 80s, 90s, and 2000s was the world's largest water treatment company. They were recently acquired by Ecolab. So now they are absolutely the largest chemical company that is in this marketplace. And then I spent 12 years in utility boiler chemical treatment with a company called Fuel Tech and Midwest Energy Emissions. And then the last 6 years I've spent on energy central plant repairs and commissioning services for Ace Energy Services and for Bernhard. I've been local to Arizona for the past 24 years. And for 12 years before that, I covered, I was in different parts of the United States, Louisiana, Texas, Missouri, Kansas, and Michigan. So that's kind of my background. And I should say, if anybody has any questions or anything as we're going through, please feel free to ask your question at that time. You won't disrupt my flow. And I think sometimes it's better just to get the question out there as we're looking at that slide. So kind of wanted to start with the challenges to the water treatment services. First and foremost, there is no standard specification for treatment. Most of it is company by company. So if you're a large national company, you probably have some very standard specifications. But if you're a local company that's in a small locality, there's probably no instructions and you're just kind of going by word of mouth or whatever feels good that's out there. So that's definitely one of the challenges. I think the water treatment industry is trying to get better. As some of the water treatment companies have been involved in lawsuits, and I'll talk a little bit about lawsuits and commissioning services on when I talk about cooling towers with a project that I was personally involved with starting up. The second bullet is most programs are proprietary, so the chemical companies don't want to share their secret sauce or necessarily their methods or their techniques on how they clean the system. The other one, and this is probably one of the most complicated ones, is water treatment is one of the last items that's to be completed in construction. And it's always like, hey, we got to get the system online. We got to get the chillers checked. We got to do all that. We got to get the mechanical side all fixed. And it kind of gets rushed there toward the end. And the commissioning and the startup services, do take some time, but a lot of times they get rushed. Like I said, in the bullet 4 says it takes time to do it right. So you can't rush this. There's always a hurry to get the systems hydro tested for leaks. If the mechanical finds leaks, they'll drain the system. They'll fill it back up. That could happen 2 or 3 times. Every time that happens, you're exposing all of the mild steel, the copper, the brass to corrosion, to a corrosive environment that once you finally do get started, you will end up with red water that's out there. And then a lot of times, and I know of a project here in Phoenix that happened 2 years ago. They filled the cooling tower and the condenser barrel with water, and then the system sat for about 6 months before they did anything with that. And so they had algae growing, bacteria was in there. This was at a healthcare facility, and there was Legionella that was found in the water. But we'll talk a little bit more about that as we come up. So that's some of the challenges. I know you folks as commission agents can probably tell a whole lot more challenges to the water treatment area and kind of what happens out there. So some of the water systems that you typically deal with are cooling towers, condenser evaporator barrels on a chiller. You got the chilled water loop, and then you have the heated systems. You have the boilers, which is both steam and hot water. You'll have heat exchangers that are steam to hot water systems out there. You could also have a plate and frame heat exchanger. And then, of course, you have the hot water loop. And the last bullet point is kind of specialty water systems. I'm seeing a lot more in construction. Yep. Somebody had a question? Nope. Okay. There seems to be a lot more specialty water systems coming in, which could be a reverse osmosis system, a water softener, a dialysis purification system. And we'll talk specifically about those, but I'm definitely seeing a lot of those in there. And some of the water treatment companies are now kind of migrating away from typical standard water chemistry to more mechanical, which involves more equipment that's out there. So those are out there, and those are kind of a case-by-case situation. So, what is one thing that all water systems require? First and foremost, they all require a plan, and that plan should be supplied by the water treatment company. I've seen sometimes cleaning plans get transferred from plant to plant to plant, or project to project to project, and they may or may not fit that particular project. So it's always good during the design phase and the implementation phase to at least have the water treatment company there for a few of the meetings to figure out exactly what's going to be required for the for this cleaning and passivation system. We need to clean all construction material and debris. Primarily, we got to make sure that there's not welding slag, metal filings, and oil and grease in the systems. All of those cause issues in some of the water contacting areas and systems that are out there. The systems need to be flushed once everything is cleaned out of there. And then there needs to be a passivation phase. And passivation phase is where you are turning the metal into or to put a protective layer on that metal. Just very similar, like if you take a shovel and you leave it outside and it rains on it, it just sits there for a while, your shovel will rust. Very similar to these water containing systems. If there's mild steel in there, or copper for that matter, they will have corrosion, they will rust, and you will see those effects downstream, which will shorten the life of the equipment. Biological control is becoming important. That needs to be part of the commissioning services, that there is a verification that they were biologically free. This primarily is concerning healthcare and water and cooling towers, where they're situated at. Legionella has become a very big concern, and most hospitals will require a clean bill of health before bringing that system online. You can also get SRBs, which stands for sulfate reducing bacteria. That is a bacteria that is specific to tube sheets on the chillers, that even though that tube sheet is an inch and a quarter thick, it'll drill right through that, and it can happen in as little as 2 years to cause that corrosion. There's slime forming bacteria. That's where if you feel inside the cooling tower basin, it'll feel slippery. If it's slippery in there, it's definitely slippery on the barrels. Typically in the condenser barrel, which causes a loss of efficiency. And then Legionella, I've beat that horse. And then finally, there needs to be an ongoing water treatment program in place for the for the systems going forward. Now, this picture is actually, yep. Somebody have a question?
Hey, Mark. Yeah. What's the best way to ask for, has the tower been pacified, or the biological controls? What's the best way to ask the GC or the mechanical for something like that?
It's a good question, Vince. So typically the water treatment falls under the mechanical contractor scope. And so I would say that, would be to ask the mechanical, number one, upfront and early, what is your plan for cleaning and passivation and biological control for your systems? And they're probably going to look at you like, I don't know. And that's the time to get a plan from the water treatment company. So, we talk in a little bit, we'll talk a little bit about how some of that is done, but a lot of it is case by case, depending on what the metallurgy is out in the system.
Sure. Thanks.
Yep. So this picture is actually that's a power plant. That was Pittsburgh Power and Light in Montour Station. And that was an old tower, but it was a wood-filled tower. And they neglected biological control in there, and they had a bunch of algae and mushrooms that grew on some of the support structure that weakened the wood. And finally, it gave way, and you can see that cooling tower just collapsed. So it was not a good day in that power plant's generation history. So cooling towers, we'll talk now about specific systems. So cooling towers, some of the common issues that we run into is number one, they want to hydro test it. Typically, as soon as it gets up there, check the piping, make sure there's no leaks. And many times that water is not treated. If it's blown down or removed shortly after the hydro test, that's okay. But if it sits, that water will get stagnant, and bacteria and algae will grow, along with some Legionella potential that's out there. One of the biggest concerns we have about cooling towers is dissimilar metals. There's a process called galvanic corrosion, and that's anytime you've got two dissimilar metals, like galvanized that butts up to stainless steel, or you've got copper that butts up to carbon steel. Like the piping or on the tube sheet, you can get galvanic corrosion. So there is a lot of different metallurgy inside the cooling tower system itself that we have to be aware of and be cognizant of. There is a phenomenon out there called white rust, and it's when a galvanized cooling tower, if you want to think about a Baltimore air coil where they have their patented Balti-Bond surface, which is a galvanized system, if that is not properly cleaned and passivated, you'll get this white rust. It kind of looks like like mold on a piece of cheese. And what's happening is underneath that white rust is it is actually peeling the galvanized surface off of the base metal, and you'll have the galvanized surface completely strip off of that cooling tower. I personally have experience with that here in Phoenix back in the early 2000s. They developed a downtown cooling district, which included the Bank One ballpark, or Chase Field as it's called now, and the majority of all the downtown buildings that were going onto the loop. They did not go with a national company. They went with a local company that did not start the cooling tower up. And within 3 weeks, all of the galvanized surface on those cooling towers had not completely, but it stripped off. And when you looked on the inside of the cooling tower, it looked like a zebra stripes inside there where it just pulled the galvanized surface off. I was brought in after the fact to repassivate, reclean both the cooling tower, the condenser, and the chilled water system after the fact. And I can tell you, it's a lot easier to do it right the first time than it is to try to clean it up the second time. Also, nuts and bolts. A lot of times in the basins, they'll have dissimilar metals there where they may have a zinc tipped lag bolt that's in there that's touching up to the stainless steel basin. So you will get some corrosion there if that's not properly passivated. Especially down here in Arizona, these buildings are hot. So a lot of times they will start the cooling towers and the chillers up prior to the water treatment guy getting set up. And the tower fill, to cool the building as the workers are in finishing construction. The tower fill can develop that crusty white material on the outside of the cooling tower. It's called drift eliminators, which can choke off the airflow, which will reduce the efficiency of the cooling tower dramatically. And then one area that I think gets missed a lot in new construction is basically the chemical control system and the bleed off valve operation. To maintain a cooling tower properly, there has to be a bleed of water so the minerals don't concentrate up beyond their solubility point. And I've seen some projects where the bleed off valve is not wired in, or the control system is wired backwards, and so they are not you're not bleeding off water, which will scale the condenser and potentially cause issues in the tower fill itself. So moving from the cooling towers, we'll move to the condenser system. So the condenser tubes, should be cleaned and passivated with the cooling tower treatment plan, and it must address all metallurgy. So the way you treat galvanized metal, what chemical you treat galvanized metal versus stainless steel versus these copper tubes, it definitely does matter. Most companies have an all-in-one cleaning and passivation chemical that will have certain proportions of all the chemicals to address each of those areas that will be recirculated for 24 to 48 hours to lay down that passivation layer. As you can see in the top picture, on the top of that tube sheet, you can already see there's the mild steel has already started to rough up. Part of that is just erosion. The water flow is causing some of that, but some of that is galvanic corrosion that just occurs between the dissimilar metals of the copper tubes and the mild steel tube sheets. Typically, those tube sheets are designed to last 30 to 35 years. So a little bit of loss each year is I guess tolerated and accepted. But when you start getting pits in between the tubes and the tube sheet is when that's of concern. But that's beyond the commissioning services scope that we're talking about here today. It's recommended that all tubes get punched prior to full commissioning. I've rarely seen that done, but with all of the new enhanced tube rifling that's in the condensers, if there's any dirt and debris that was left in the cooling tower that got sucked up into there, or construction debris, that could be one of the areas that as you do your commissioning, if the chiller is not meeting the kW per ton that's rated, it could be just due to fouling inside those enhanced tube riflings that's in there. By punching the tubes, that would eliminate that from being in the rifling. We need to check and clean all pump strainers. It's amazing what you find in pump strainers during construction. I found 2x4s. I found a crescent wrench. That they just end up in there, and that can truly damage the impeller if it gets past that strainer. So those should be checked. And then the tower drain that goes to the main flush valve. That should be a strainer on that. That needs to be checked as well. And the evaporator barrel, that'll be treated as part of the chilled water system. So I don't have a separate slide for the evaporator, but that'll be treated because that basically is a closed loop system. So do I have any questions so far? Nope. Okay.
Got a bunch of shy people out there.
That's all right. That's all right. So closed loops, this covers both the chilled and the hot water. There is potentially a lot of dissimilar metals, I should say a ton of dissimilar metals that are out there. You got copper, iron, brass, zinc, galvanized. All of that needs to be addressed. And a water treatment company needs to know what the metallurgy is out there so they can design the program to meet each of those. And it's highly recommended that the use of dielectric unions that are out there. So if you guys are out in the field and you're looking at systems, and you see a copper, pipe directly plumbed into a mild steel pipe, we probably need to get a dielectric in there. There was a hospital here locally in Phoenix that I was called to, that they're plugging strainers on their hot water loop, and about every 2 weeks they're having to clean out the strainers. As I walked down the system, it came out that there was no dielectrics in there, and there was like 26 points where copper was tied directly into mild steel. And so when they went to go put the dielectric unions in there, they could actually see the wearing on the mild steel pipe where the threadlet was, where it was actually the corrosion process was already starting in there, and they would have had a failure, and that was on the 4th floor, right above the surgery suites. So that would not have been a good day in that hospital. One thing is on the chilled loop, and especially here in Arizona, is we may need to adjust the pH and the chloride content. We have a very high pH and a very high chloride containing water, which may mean that you may have to mix in a little bit of reverse osmosis water or purified water in that, or somehow reduce the amount of ions that are in the system itself to reduce some of the corrosion. And once again, the water treatment guy will recommend you for that. I cannot stress the next one enough. Do not fill the loops without treatment. You will get rust, and it will clog up the strainers on the air handlers, fan coil units, your terminal units. Anywhere you got one of those little strainers before it goes into a coil, they will plug up. There was a major resort here in south of Phoenix area that started this up without treating the chilled water system, and every fan coil unit had to be gone out to clean the strainers because they did not do this, and they ended up spending a lot of time, effort, and money to get the system back under control. Air water separators must be installed and functioning. Entrained air in water is not good. It's not good for the pumping. It's also not good for the water treatment because oxygen will promote the oxidation of metal. So during the process, we need to make sure we blow it down to remove the solids. This picture kind of shows just a standard air water separator here versus there's a couple of companies out there now selling cyclonic filtration. This particular model is called Sweep Clear. It's one it also has this media that's inside of here. This looks like slinkies that it slows the metal particles or the dirt debris down, goes into a blowdown line, and then from the blowdown line you remove the sediments. And they claim that in 72 hours you can take a real dirty loop to a clean loop. So the testimonials are pretty powerful, so that may be something to look for. And then filtration for a closed loop, if treated correctly from day one, you should not need to filter the loop. But if you don't start up from day one, you will need to filter it. And once again, the water treatment person can recommend and do make arrangements for that filtration to occur. Typically, it's done side stream, and you'll run a slipstream through, maybe 100 gallons a minute through a sock filter or a pleated paper filter, just to remove that, and then that'll need to be cleaned periodically. And then you can also step down through the different micron size to get to clean water. Here's a picture. A gentleman from ChemTreat, which is one of the national companies, sent this picture. This is just a dirty copper heat exchanger tube. This did not occur during startup, but I thought I'd throw it in there just to show that even in a closed loop, there can be some dramatic corrosion that occurs, inside the system, and it's typically noted by this red material that will deposit, and you get under deposit corrosion, which is similar to taking a drill bit and just running it through the pipe itself. It cannot stand under deposit corrosion, and you'll start to develop pinhole leaks. If you get one pinhole leak, you can almost bet that you're going to have others that are out there. So once again, make sure the mechanicals and the water treatment guys have a plan and they're on top of what they're doing. Moving into boilers, hot water boilers are treated just like chilled water systems. Once again, cleaning, flushing, passivating, biological control if it's a low temp. If it's over 120-degree water, you probably don't need to have any biological unless there's dead legs that are in the system. So that would be something you would need to address, and the mechanical can let you know if there's dead legs out there. Typically, a dead leg would be if they've got piping that's run for future expansion, and they've got like a 20-30 foot run of pipe. That water can become stagnant, which can be can become a growth area or a petri dish for bacterial growth. Steam boilers is another beast, another kind of an animal out there that cleaning of all oils and greases in that boiler itself is imperative. If any grease or oil is left on the tubes, and primarily I'm talking about fire tube boilers, they will develop a hot spot, which could result into a blown tube and issues with the boiler not being able to stay online. So that cleaning and flushing is pretty standard. And ironically, it typically uses a pH adjustment and borax laundry detergent. So it's very high tech, but it works real well to get that out of there. The flushing of all debris and cleaning material needs to be taken out of there, because there are some scale forming compounds that you're putting in there, the detergent, and so you don't want to do that. And then when you fill it back up, you'll need to do pH control and passivate the boiler. And then typically you'll start the boiler up at that point. And then we need to not neglect the steam condensate return lines. That's lines where the steam goes down, the energy is taken out of the steam, and you get the condensate return that's coming back. That entire system needs to be passivated. And in this particular case, air is the enemy. So if there is any, typically we like to say, once you start a steam boiler, we need to keep the steam boiler going and keep steam in those lines to keep the air out. So kind of keep it pressure positive. It's in there. The other thing to watch for as a commissioning agent is always have the mechanical and the boiler startup people shut the system down while you're there, and watch the DA, which the DA stands for deaerator, or the feed water tank system, because there's transient water that will come in, and typically that will overflow. And if that overflows, you've lost all your water treatment, and then when the boiler starts back up, you will be you'll be behind the deficit, and that can lead to corrosion and scale buildup inside the boiler itself. I've got a plug out here for Patriot Boiler. They're a company here based out of Phoenix, and they have been very responsive, in my opinion, to boiler concerns, boiler startups, and they can actually assist the mechanical, with the startup process, even if they didn't buy the boiler from Patriot, and I think they rep Johnston Boilers is their main line of boilers that they rep. The fire tube boiler that's on the left there, that happens to be, I think it's a Cleaver Brooks. So anyway, kind of moving into specialty water systems. All I can say on this is consult with the manufacturer. Most of these, for the RO units, the dialysis machines, any kind of dealkalization, they will have a rep on site during the startup to make sure that it goes well. Most of these systems come with a startup plan or a startup service as part of the installation. Make use of that. Make sure that if it's not included, that somebody at least has a plan to start these up. If you start up a reverse osmosis equipment in the incorrect manner, you can destroy the membranes in a matter of minutes. So definitely that needs to be something that's followed step by step, and that the manufacturer is integrated into that startup system. All systems are different, and they all have proprietary material that can be damaged if not treated correctly. So that's kind of my way, of saying, hey, CYA, make sure that the mechanical or the owner has somebody there as part of the startup plan to make sure that those systems are taken care of correctly. So for you young people in there, the guy up in the upper right-hand corner is Alfred E. Newman, and he was from Mad Magazine, and his kind of trademark line was always "What me worry." So I kind of added that by what can go wrong, and I just kind of off the top of my head, I just added some of these on there on things that I've seen before, where the contractor does the hydro test. We've already talked about that, and then it just sits for extended periods of time. You will get corrosion. You'll get bacterial fouling. You'll get material fouling, which is basically silt, especially if a monsoon blows through. The cooling tower sucks in all that dirt. Or on the other consequent, if you're not, the water treatment guy is not set up yet, you can overcycle the tower water. You can scale the tower fill and the condenser tubes inside the chiller itself, which would require an acid cleaning and a lot of finger pointing on who covers that cost and all that good stuff that goes along with that. If the contractor has to drain the loop for any reason, definitely needs to be retreated and potentially cleaned or filtered if any contamination is introduced. A lot of times I've seen this is if you have multiple chillers coming online, and you're bringing on the chillers individually and kind of not all at the same time, you'll want to make sure that each of the evaporator barrels are treated at one time, so the entire system is treated, and try not to do it all as you step down the line of chillers. And it requires some coordination with everybody, which goes to the next point. A lot of times the water treatment company is the last people that are notified. There's no coordination. So as commissioned agents, bring up water treatment early and often and get them a seat at the table. They probably don't need to be at every meeting, but like I said earlier, they need to be at some of the meetings and have a plan that they're able to initiate and to implement. I've seen some mechanicals, they completely ignored the water treatment recommendations. It was cut out due to cost. Mechanical contractor had a cost overrun. Completely, took that out, and the consequences is that ended up in a lawsuit that me being the water treatment guy who was cut out of that process. Basically, we had to provide photographic documentary evidence that that we never did the startup, and B, there was repeated attempts at us to do that. And so we don't want the mechanical contractor on the hook for something to replace cooling towers or replace chillers or whatever out there. And then sometimes the owner will value engineer the water treatment process out due to cost. And I kind of put in there, it's an investment into your high dollar systems so your systems last for the expected length of time that you're counting on them to survive. If it's 15, 20, 30 years, chillers are not pieces of equipment that get thrown around. Did a project last year that they had chillers that were in there, probably not very efficient, but I think they were from like the 1960s and they still ran them. So, if water treatment is done correctly, your equipment will last. So that's kind of my last slide. Well, I got one last slide. I have this up there. These are 3 reliable water treatment companies that are national, along with a point of contact for each of these. So, kind of take your pick. I know all 3 of these folks personally, so would recommend any one of these. So if you have any questions or you're on a project that they didn't include water treatment, these would be some good folks to contact and get them involved in the process. So with that, Vince, that's kind of my presentation, and I'll open it up for questions.
Okay, cool. Nothing in the chat, but is there any other questions out there within the chapter, or anybody got anything, horror story, something that went well? Right, we're not always about picking the things apart. Anybody's got some good things to get the water treatment into the process that has worked for them?
Well, they are a shy group, Vince.
Yeah, they are a shy group. Okay, well, with that, there's a chat that just popped in. Oh, so thank you. So with that, Marcus, I appreciate it. On behalf of the BCA, thank you for jumping in. And next time I'm down in Arizona, I owe you a few beers.
A few. I like that term, a few.
Yeah. All right.
All right.
Everybody,
Thank you,
thank you for your time. Appreciate it.
Yep. See ya.